In this video, we're going to look at a way where we can identify what charges our ions are going to have just by looking at our periodic table. We already know how to identify the number of valence electrons. So we know if we look at group 1, we're going to have 1 valence electron. In group 2, 2 valence electrons. Our transition metals don't necessarily follow a pattern, but if we go over here to group 13, we're going to have 3 valence electrons, 4 valence electrons, 5 valence electrons in that group. Group 16, 6 valence electrons. Group 17 would be 7. And group 18 would be 8 valence electrons, except helium, which just has 2. And we know that our metals are on this side of the periodic table, and our nonmetals are on this side, and we have our staircase right here separating them. And the ones I didn't color, these are metalloids, so they can have properties of each. So if we take a look at some of our elements, we're going to start with some metals. So if we take a look at lithium, when lithium forms an ion, it wants to lose its valence electrons, just like all metals. And then it has 3 protons and 2 electrons, so it has a plus charge. So every element that has 1 valence electron that loses it is going to have that same charge. So in group 1, lithium, sodium, potassium, all the way down, when they form cations, they're going to form a plus, I'll put 1 here, a +1 charge. And you can see there's going to be a pattern, because as we go to our second one, we're going to take a look at calcium. It's an element in group 2. And it wants to lose these 2 electrons. So when it does that, it'll have 20 protons and 18 electrons, giving it a +2 charge. And every element in that group has 2 valence electrons. So when it forms an ion, they will all form +2 ions. Move into group 13 with 3 valence electrons. If we have aluminum here, aluminum wants to lose these 3 valence electrons to get a full shell of valence electrons. So it'll have 13 protons, 10 electrons, giving it a +3 charge. All the metals here are going to have that +3 charge. So remember, ionic bonds have to be between metals and non-metals. So we're not going to count boron here. So down here. Let's take a look at some of our non-metals now. Let's take a look at fluorine first. So fluorine's in group 17. And our non-metals want to gain those valence electrons to fill the shell. So if we take a look here, we're filling up our shell by gaining 1 electron. So we have 9 protons and 10 electrons for fluorine. So because we have 1 more electron, we are going to have a negative charge. And that holds true to all the elements in that group. So all the elements in group 17, when they form ions, are going to have a -1 charge. If we move to group 16, oxygen has 6 valence electrons, and it wants 2 more to fill its full octet. So it'll have 8 protons and 10 electrons when that happens. So it has 2 more electrons than protons. So it has a -2 charge. And this is true for the other non-metals in this group. Not true for polonium. Polonium is still a metal. It'll still want to lose those electrons, the valence electrons. But it's true for these non-metals here when we're talking about ionic bonding. And if we take a look at nitrogen, nitrogen has 5 valence electrons. It wants to fill these up by adding 3 electrons. So it'll have 7 protons, 10 electrons in total. So its charge will be -3. And that's true for the nonmetals in this group, nitrogen and phosphorus. Carbon generally doesn't want to form an ion because it has to either lose 4 or gain 4. In general, it usually loses 4, but it doesn't really want to form ionic bonds because losing or gaining 4 electrons is a lot. So we're going to focus in these 6 groups right here. So these 3 groups that are metals and these 3 groups that are nonmetals when we're thinking about ionic bonding. One other thing, all our metals, if we notice, they're going to be plus, and when they're ions, we call plus ions cations. So going back to that vocabulary, you may have noticed all our nonmetals are negative ions, and if you remember, our negative ions are called anions.